I'm here to show you today is the industry's highest performance inference processor. And we believe that this performance level will be key to scaling AI. And here it is, with 15,000 images per second on the ResNet 50 benchmark. And this number is not based on a simulation or an FPGA or even a test chip prototype. This chip is production ready today. In fact, we started sampling it to select customers. So let's put 15,000 images per second in context. In the CPU category, a dual socket Platinum achieved 1,225 images per second. And this one, by the way, was measured with a batch size of 64 and 4 instances, referring to Mark's comment yesterday about batch size. In the GPU category, a V100 GPU, having to balance between latency on one hand and throughput on the other, is achieving 2,657 images per second. And in our category, what we call AI processors, the HL-1000 delivers 15,000 images per second, over 12 times faster than the fastest dual-socket CPU, and doing that while delivering a latency of just 1.3 milliseconds. So that's well below what's required for real-time applications. And all that while consuming just 100 watts. So what you're really seeing here are two industry world records. One is the throughput world record, 15,000 images per second on a single processor. And the other one is the efficiency. Divide those two numbers, and you get 150 images per second per watt. And you got that while removing the need to compromise in latency. You can serve real-time applications and non-real-time applications. Now, at this point, some of you are probably skeptical, and you should be. Too often you hear stories about an AI performance breakthrough just about to arrive. What you probably want to see is that this is real. This is not just a story. So to do that, what I'll show you here is a video we took in our lab showing the actual product and PCIe adding card with our processor inside in a real server, and you see the benchmark running and the performance being measured. What you see on the left side are the Linux kernel log of the host CPU giving our software stack 15,000 images and measuring how long does it take for result to be back in host memory. So that includes host latency. And you can see the images per second consistently, 15,000 images per second. And if you'd like to see that live, please come to our booth outside. We'll show that to you live. It's running the complete software stack with a chip in a server running the benchmark. So, what do we do with this throughput? How do we scale AI with inferencing? So, you've probably seen these two images before by some other keynote. This one explored how many CPU servers versus how many GPUs would you need to support a throughput of 45,000 images per second. Well, with our 15,000, you guessed it, you need just 3 AI processors by Habana Labs. You buy 3 cards, put them in your existing servers, and you're done. And while doing that, you also get real-time latency. And that's how we believe AI scaling should look like, whether it's in a data center or any other emerging application that requires throughput, low latency, and the best-in-class size and power consumption. Now, our processor and software stacks are designed to support any topology. And to show you that, outside in our booth, you'll be able to see running live 4 of the most popular topologies. You'll be able to see a recommendation system. This one is based on MLPs, multi-layer perceptrons. You'll be able to see the ResNet 50 topology based mostly on convolutions. You'll also see neural machine translation, With this one, we took an LSTM-based sequence-to-sequence topology from the SOCI project, and we'll show you English to German translation. And we'll also show you an LSTM-based sentiment analysis application. This is a general-purpose AI processor with software stack that will support any topology, whether it's a recurrent topology, or CNN, or any other. Now, until now, I talked about inference. I presented to you what we see as the highest performance inference processor today. But I also want to talk about training. Now, at Habana Labs, when we look at training and inference, we see a world of difference in requirements. These require very different compute, very different memory, very different latency and power envelope. So, designing one processor and using it for both would have meant asking our customers to compromise on the performance, on the power consumption, on the cost. And we don't want to do that. We want to have best in class in both. So Habana Labs is delivering two product lines. The Inference product line, our Goya product line, has its first member ready, sampling commercially, production ready. That's what you see in the left, and this is our PCIe line card, one of them. Our training solution, though, is not far behind. On the second quarter of next year, we'll be sampling the first member of our Gaudi product line. For more details, please come to my session tomorrow. I'll go into much more detail on the performance capability of our products. Please come stop by our booth to see the demos. Thank you very much.